Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. And hi everyone. So welcome back. Alright, so we need to discuss about a special type of relation. So please make sure that you are still with your notes now. Alright, so a function, so please write function on your own notes, is a relation from set A to set B such that every element of set A is matched with only one element of set B. Alright, so we have four types of relations that we have discussed in our previous video, where we have one-to-one relation, one-to-many, many-to-one, and many-to-many. So based on this definition, alright, so only one-to-one relation and many-to-one relation can be considered as function. Right, so let us try to discuss this example where we will try to represent this function as mapping for this case, right? So we have set A of the element of 3 and 4, and set B, which is 6 and 8, and we have the law of correspondence, which is a factor of. So let us try to write first the law of correspondence here. So basically F is equals to a factor of, and we've got the set A, which is 3 and 4, and set B we have 6 and 8. So in order for any relation to be a function, each of the element from set A must match with only one element in set B. So 3 is a factor of 6, so we can draw the arrow like this, and 4 is the factor of 8. Alright, so we also can represent this function as ordered pairs. So basically we can write in set form. So we will write 3 and 6, and we also have 4 and 8. Alright, so let us move to the definition of domain and range. Okay, so domain is actually the set of all real values of x such that fx is defined as real number. So usually we will refer to the interval of x, and it can be written as the domain of f like this, df. Alright, so what about range? So range is the set of all possible real values of fx for each value of x in the domain. So usually refer to the interval of fx, which can also be written as rf here. Okay, so to make you more understand about how to get domain and range, let us consider this axis here. So for you to read the domain, we actually read the domain on the x-axis. So it's basically like this. So this is your domain, and we read the domain from left to right. So we will discuss this on the next example. And the range is basically referring to the interval of y. So let us write here range, and we should read the range from the bottom part of the graph to the highest part of the graph. Let us write it as the bottom to the up here. Alright, so let us try to consider these two graphs. Okay, so the first one, so this graph is actually of the function fx equals to x squared, where it is the quadratic function. Okay, so in order for us to get the domain and range, let us write it as rf and df. Okay, so let's start with domain first. So domain, again, we usually refer to the interval of x. So try to imagine that we are walking on the x-axis and we try to look the graph from the x-axis. Okay, so when we are at this point, at this particular point of x value, we can see the graph is here, right? And we have no idea where the graph stops. All right, so which means our domain should start from negative infinity, and suppose that when we try to continue our journey along the x-axis, all right, so we still can see the graph here. Okay, so what about this one? We can still see the graph here, and so on. Okay, so we have no idea when the graph stopped, which is therefore our domain should end at positive infinity. All right, so what about the range? So again, for range, we are looking at this interval of y. Okay, so basically, imagine that we are walking along the y-axis here and try to look for the graph at the from the y-axis. Okay, so there is no graph here. All right, so and we try to move along up to this point here where we can start to look the graph at this point, which means our range is starting from the point 0. Okay, so when we try to continue the journey along the y-axis here up to this one, up to this one, so we can still see the graph from that y-axis, so in which we have no idea at which point does the graph end, so which is therefore the range of this function should end at positive infinity. Okay, so try to look for the second graph here, right? So where this is the function of square root of x actually, and we need to try to state the domain and range of this function. All right, so as we try to look from the x-axis here, there's no graph here, but the graph do starts at 0.00, which means our domain starts from 0. And suppose when we try to continue our journey along this x-axis, we have no idea when the graph stops. All right, so which is therefore we can say that the domain stops at positive infinity. Okay, so what about the range here? All right, so again for range, we are looking for the graph from the interval of y. So imagine that we are starting from here. So when we are here, there's no graph along here. So we continue our journey, and at the point of 0, 0, then we can see the graph starts. And what about this one? We can also see the graph here, and also and so on. All right, so which is therefore we also have no idea when the graph ends. So basically, since the graph starts at 0 by looking from the interval of y, so the range is also starting from positive 0 up to positive infinity. All right, so so these are the exercise 4.1 that you need to do in order for your attendance for this online class. All right, so all the best. That's all for this chapter 4.1. Hope you understand. Thank you for listening. Thank you for watching. Bye.